I've always admired bees and I've used a honeycomb pattern in many of my projects, so I thought I'd build something that not only looks like a hive, but actually simulates one. My current setup is an IKEA corner desk. I like using it as it fits well into the room, so I'll reuse the general shape. The hive will use hexagonal frames, even though rectangular ones are the norm. This model shows the layout with 74 frames in total. Areas are left clear on the left and the back for laptops and such. There'll be 44 frames that will actually light up. The first thing I do is design the frames in Illustrator. They're made of 5 layers with 37 cells each that decrease in size to give a 3-dimensional feel. To cut them out, I bought this CO2 laser cutter. It's an OM Tech K40 Plus, not sponsored. It's the cheapest I could find, which looks ready to go, and on the whole has been a decent choice. 2mm laser plywood is used for most of the layers, although I later found out the thickness varies. I want a way to show the status of a cell. To do this, the middle layer has hex inserts made from acrylic, which are lit up using behind from a light rod that comes through a separate hole from behind each cell. For a prototype, I used clear acrylic, but sanded to give the light a surface to emit from. I stained the plywood to match the top layer using natural oak. There's links to a lot of the products used in the video in the description. Being a desk surface, it needs to be flat. A layer of acrylic over the whole thing would work, but I want to feel the wood grain. Each cell could have an acrylic cap, but it's difficult to sand flat and doesn't look good when lit up, so the answer is to fill all the cells with epoxy. The clear acrylic rod will be used as a light tunnel to show a bee's presence in a cell. I found painting them stops light leaking out into the surroundings. I tried various materials for the hexes, but settled on Perspex 030, which let through about the right amount of light. It came in 3mm thick sheets, and thicknessing them down to 2mm to match the other layers was a bit of a pain, so decided just to go for 3mm after all. So it's time to start mass producing the frames. This little lot is just some of the building materials I end up needing. It's cheaper to buy bigger sheets of a laser cutter, but they need to be cut down to fit on the build bed. The top layer of the frames is made from Morocco, an African hardwood which will match the rest of the desk. The frames are 120mm across the shortest edge. A little extra is also needed for laser cutter clearance. My little bandsaw can only just about accommodate this. The stock is ripped down to about 125mm wide and then chopped into shorter lengths. Then it goes through the bandsaw, very slowly. The multi-tooth blade I had on there takes forever and produces a fair bit of insidious smelling smoke. Swapping to a fresh rip blade makes a world of difference. Much quicker, no smoke, less heat, so the resulting strip stays nice and straight. The thicknesser needs a sledge to send through thin stock, so I CA glue each strip to a piece of plywood using masking tape and send it through to give smooth 2mm thick strips. A plastic wedge is then needed to release them afterwards without splitting the thin wood. And that gives me a pile of around 74 blanks ready for the laser. Next it's onto the hex inserts. First the sheets are cut on a table saw, then the laser does its thing. Or at least it did, until the breaker popped and everything went dark. Afterwards the laser refuses to power on. A bit of probing with multimeter shows the laser power supply is completely dead. OM Tech support were great though, and sent out a replacement in a few days, and I can get back to cutting again. Each of the frame layers needs cutting out now. I can do 2 at a time. There are 4 plywood layers and 74 frames, which are 148 operations, plus 74 single Roco cuts, for a total of 222 operations, not including the sheets of hex inserts. As all the parts are cutting out, I'm also staining and gluing them together. Here I'm using a rubber roller to spread a consistent amount of glue on each layer, which is aligned with the previous layers using a couple of dowels. I need to make sure all the frames are the right way around, so all the light tube holes match up on the bottom 2 layers. I use a jig cut on a CNC and lined with packing tape as a guide for the top layer. The direction of wood grain is checked so all the frames have a grain going the same way on a finished desk. A spacer is added on top of a frame to make sure it's pressed in the right places, and then it goes into the press. And this is the main bottleneck in the frame making process. I'm doing about 3 a day on average, before work, after work and before bed, which works out about 25 days to get all the 74 frames done. Packing tape makes a great non-stick surface for the glue roller, with the less said about this thing the better. Now I need to make the rods for the cell centre points. This brown direct plastic paint works great. I start by cutting the rods into pieces and then painting them, but it's slow to do and the paint is cleaning off the end. So instead, painting them first and sticking to masking tape running through the laser produces fast cuts with polished ends. The rods are glued into the frames using UV curing epoxy. Each one is aligned in the cell to point upwards and then set in place. This takes a long time, but ensures the positioning is good and not much epoxy leaks out the bottom, especially later on. The work surface is covered in packing tape anyway, so for any leaks they shouldn't stick. Now I mix up some 2-pot craft epoxy and paint it into the inside of each cell as a seal coat to fill in any remaining gaps in the bottom. This is to prevent leaks and try to lock in the soot from a laser cutting. I've left it around 6 hours for the seal coat to semi-harden. Now more epoxy can be poured in to fill up the cells completely. It's the hottest day of the year today, and even this small amount of epoxy in the tub has gone exothermic and suddenly turned solid. Despite my precautions with the seal coat, there are still a lot of bubbles coming up from between the layers, so I've got to keep on going over each one with a needle to loosen them up so they float to the surface and can be popped with a blowtorch. It's a couple of days later now. The epoxy is fully cured. Most frames are leak free, but a few still have patches of epoxy on the bottom. These will need to be sanded back to give a flat surface for the next step. Now it's over to the CNC router where I've got a jig set up to hold the frames. It has a notch on one side, so I should be able to pop them out again afterwards. A 1-inch surfacing bit is run over the top until the epoxy is level with the wood. The plywood used to build the frames was slightly different thicknesses, and the amount that needed to be taken off the top varied, which meant the frames were not consistent thickness. I can't take too much off the top layer as it will be visible, so each frame is flipped over and the bottom is surfaced. Now all the frames are within a few tenths of a millimetre, so the whole lot is surfaced again, but this time without adjusting the CNC height, so they're all exactly the same thickness afterwards. So in total, that's 222 different operations on the CNC router. Never again. I put together a couple of programs in Python to run the Hive. The first is a builder program, which allows a hexagonal base grid to be defined. Frames can be deactivated, pathways configured, and their order set. This is then exported and used by the second bit of software, the simulator. This works from a series of rules about each bee. Basically, the queen looks for empty cells and lays eggs in them. She needs feeding to do so attendant bees get food from storage and feed the queen. Nurse bees feed the eggs. Bees take a certain amount of days and feedings to hatch. Forager bees leave the hive to gather food and then place it in storage cells. As bees age, they progress through the different roles before they become foragers until the end of their days. The simulator will run on a Raspberry Pi 5. and uses 5 different SPI channels to allow control of the 3,745 LEDs the Hive uses. I started off the electronics with a mock-up built from a WS2812B addressable LED strip. These LEDs are physically too big and spaced too far apart to work as is, so I need a custom built PCB. To do this, I went for the sponsor for this video, JLC PCB. Using their design software, EasyEDA, I put together a PCB which would exactly fit each frame. EasyEDA has access to all the components that JLC offer, and using this I found a mini version of the LED, which meant the components could fit together nicely instead of being crammed together. Then it was over to JLC PCB's website to place the order. It was easy to upload the files and get a price straight away. I went for the assembly option, so they would come with all the LEDs already soldered in place. There were options to specify baking, which the LEDs needed prior to soldering. Then I could see what the boards would look like with the rails and V-cuts needed to produce a hexagonal PCB. I also ordered a panelised board of short strips which would go in between the frames to provide pathways for the bees to get around the hive. Not long after ordering, I've received the delivery in the post. The PCBs are great quality and all work reliably. Thanks for JLC PCB for sponsoring this video. I ended up using a pair of pliers to break all the V-cuts to separate the boards out. Back to woodworking, and now it's time to build a structure for the top. This is 18mm birch plywood and is the most expensive plywood I've ever purchased, but it's lovely quality with no knots or voids, which is essential for this project. I cut it down using a track saw until I've got a basic rectangle, then a section is cut out to turn it to a right-handed corner desk shape. Now I can place all the frames and see for the first time roughly what it's going to look like. Next, the rough position of the frame's outlines needs to be set, ensuring the frame's edges are lined up with those of the baseboard. That done, I can start thinking about the surround which will contain the frames. Roughly cut Iroko boards are laid out, and then the thickness and widths tuned to make something workable. Miters are then figured out and cut into the pieces. There's a lot of time and work which goes into making projects like this. If you like it, please consider subscribing to support the channel. The frames need to fit into the surround, so I'm going to do a quick spot of template routing. Using a template cut on the CNC, I mark out the position of the first frame, and stick it to the piece using double-sided tape. Now I'm using a jigsaw to cut out the bulk of the material and a spiral compression template bit on the router table to match the template's profile. Working along each piece of the surround, this is then repeated all the way around. I made a miscalculation on the width of the last piece and had 2 triangular holes. so glue a couple of bits in to fill up the spaces. A layout block and pencil mark out a 20mm overhang between the baseboard and surround, which is then trimmed back. The surround piece is now glued and clamped in place. The offcuts from when each surround piece was initially cut were saved to fill in the area underneath and match the grain of the piece above, hopefully to look like one solid piece of wood. Then you'd cut into shape, mitering, then gluing in place. The edges can now be cut to final dimension, with the tracks are used for external edges and a router for internal corners, which made quite a mess. The laser cutter is far quicker for cutting templates than the CNC is. 3mm plywood seems fine for the job. They're stuck on, and the router used again with a spiral template bit to create the corners. A quick go over with a 1/4 inch round over bit finishes the surround for now. With the surround sorted, I can return my attention to the frames, which due to the fixed surround now set in constraints, don't all fit anymore. Each frame is numbered, and then the edges are sanded down until they fit in. Lining paper is used as a spacer to standardise the gaps between all the frames. With all those done, the frames without LEDs are then glued down using wood glue for strength and CA glue for quick clamping. There have been quite a few repetitive tasks in the project so far, cutting and assembling the frames being the worst, until now. There are 44 LED frames, each requires 74 holes for a total of 3,256 holes, plus 612 for the pathway LEDs, a grand total of 3,720 holes that I need to drill, basically by hand. Each one is marked using guide and punch and drilled out with the help of a drill guide. Oh, and there's 2 different drill sizes per frame. Once each hole is prepared, some 5-minute epoxy is mixed up. 4 light bars are inserted into their slots in the frames to act as positional anchors, and the frame is pushed into place. Epoxy is used as it's colourless and shouldn't affect the light. The process is repeated for each frame and takes many hours to complete. After several days of drilling and a saw arm later, I can move on to the pathway holes. The frame edges have the holes pre-cut, however they don't always go together nicely. If you try to drill them as is, there's a load of tear out as the drill tries to find the path of least resistance. So I need to go over each hole with a burr to create a nice round hole for the top layer. Now we're flipping the desk over so the holes can be sanded and cleaned out. I'm masking off the pathways to act as a barrier to keep the next lot of epoxy in. I'll use the same acrylic rods as before to go into the holes to act as light tunnels which transmit the LED light to the top of the desk. I cut my laser cutter and then epoxied into place. The top of the rods are set about 1 millimetre below the surface of the desk. Finally, the holes are filled in with some more epoxy. Here I'm using a rod to do it, which is way too slow, and the epoxy starts to thicken up, so I end up just pouring it on. For the second batch, I'm having more success with a syringe. Now it's hardened, I'm using a belt sander to remove the excess epoxy and smooth out the whole desktop. A few holes need to be dealt with by cleaning them out with a pin and filling with UV epoxy. Now it's getting a rough sanding at 180 grit with the orbital sander to get rid of the marks left from the belt sander. After flipping the desk over again, the masking tape, which did a great job of stopping leaks, is removed, and another laborious process of sticking in round and square light tunnels can begin, this time with 5-minute epoxy. These can all be then sanded back to give a nice flat surface. I decided to reuse a stand from the old desk, but I will paint it black to match everything else. I'm not a metal worker, and building something else just seemed unnecessary, especially given how long the top has taken so far. So I'm marking out the position it will go in, and then building a substructure from more 18mm ply, which will match up with key mounting positions. This needed template routing in the same way as the surrounded to allow space for the frame edges to fit in. A couple of channels are cut in to give a cable somewhere to pass from the frames to the pie and the power supply area. The individual frame pieces are then dominated together and then glued up, using packing tape under the glue joins so the whole thing can be clamped to the desk while drying. A few offcuts are used to make a template which overlaps the substructure, and then both pieces are moved to a couple of sawhorses for yet more template routing. A small router bushing is used to transfer the shape onto the template. The rabbiting bit can then cut a recess into the substructure, doing a couple of passes to get down to the desired depth. This is what the cover will fit into. The router is now used over larger bushing to transfer the inverse of the shape, which is slightly larger, onto a sheet of 6mm ply. This cover will now fit nicely in the recess. The substructure can now be glued to the rest of the desk. Moving on, I laser cut a load of 2mm thick spacers which the LEDs fit within and stick them over the holes. After doing all of that, I need a bit of a change, so I'm staining the ply with natural oak to best match the Iroko. Using similar template routing techniques I've shown before, off camera I've made these pieces from Iroko have a 45-degree profile to fit around the edges of the ply. Once glued on and sanded, they leave a small lip before the edge of the desktop. From above, this makes the desk seem quite thin, until you go low enough and see the 45-degree chamfer, which helps soften the total thickness. These triangles, which are the same thickness as the bottom of a recess, are added as mounting points for the threaded insert to give the cover something to attach to. Just like the frames, the pathways need spacers attaching to, over 130 of them. Now it's back to the top side for final sanding and polishing. I'm not going to show all the steps from 180 up to 4000 grit as it's really dull. It's now polished using a special epoxy polishing compound, and afterwards it's lovely and see-through. But now, after finishing that, it gets wiped down with white spirit to clean off any dust and residue. And a coat of hard wax oil to seal it all in. The oil darkens the colour of the wood and makes a great pop. It's looking really nice now, and you can look down into the cells. Apologies though to any trypophobics out there. The next step's wiring up all the electronics. I solder power cables to each frame and daisy chain the data lines, using the frame numbers from the builder program to dictate the order, and each one's screwed in. Next, the pathway segments are laid out. The builder program shows if a segment should be 4 or 5 LEDs long and the direction each segment should go in. The PCBs have vias in a place that enables them to be easily cut down from 5 to 4 LEDs with a Stanley knife. The smaller power wires for several pathways are soldered together along with a slightly thicker cable used to connect to the main feed. Using silicone wiring for this makes things a lot easier, as it's soft it bends more and is less likely to break the solder point. Ask me how I know. The actual order of the segments is decided while soldering all the data lines together. This is then uploaded into the builder program as I go along. All in all, I needed about 700 soldered connections. Even the dog was bored at this point. I already had some really thick cable knocking about, so I used that as the main feed, although it's total overkill. I then used slightly thinner cables off that to go into Wago 221 connectors, which everything else I went into. I've just checked nothing's shorting out, so now I can connect it to a bench supply. At standby, with no LEDs actually emitting anything, takes over 2 amps. At the back right of the desk, I drilled a hole and pulled through cables for the entrance pathways. Now all the PCBs under the desk are connected up and ready to go, so the back cover is bolted on. Lastly, I just had a bit of finishing left to do on the back with some hard wax oil. Now it can leave a workshop and go up to the study. It needed 2 people as this thing is really heavy now. I've propped it up against the wall and then used a frame from the old desk to mark out the hole positions. These are then drilled and the threaded inserts put in. It's a big moment now. After 6 months building a desk, we lift it onto the frame, bolt it down, and can finally see what it looks like in place. For the entrance to the hive, I thought it would be an interesting idea to replace the monitor stand with a fake one, with the entrance pathways in it. To do this, I'm wall mounting the monitor to a helpfully positioned stud. A base for a stand is cut out, which is the same size as a frame, with holes along one edge. Next is the stand itself with hole spacing that matches the pathway LEDs. The electrics are attached to a laser cut insert that was a push fit into the stand. The holes are then filled with UV epoxy with mica powder mixed in to diffuse the LEDs. Using the UV epoxy this way is really quick, although there are a few voids which needed refilling. For the back of the stand, I've laser cut out some pieces to extend it out a bit, and then add a cover which push fits into place. After finishing with hard wax oil, it's put in place and connected to the cables coming out the back of the desk. The wiring gets wrapped in loom tape to tidy it up. On to finishing touches now. The Pi needs an external power button, so a head is soldered on and a button panel cut out and mounted to the desk. The other button will be used to restart the simulation. The Pi is mounted and a fan added to ensure things stay cool. I'll mount the power supply and create a cover for this area later. So over 6 months on, this is the final result. There's so much bee behaviour in real life that is complex and fascinating. Distilling this into a simulation can never be more than a simplified copy. However, watching a hive at work is hypnotising. Each one is different. Sometimes the hive prospers, other times it dies away quickly. Regardless, there will always be another queen for the hive to live on.